Okay, we quickly calculate the acceleration of the charge, which was the last question on the first problem. The acceleration is force divided by mass. We're given the mass, and we found the force. When we do this division, we divide newtons by kilograms, gives us meters per second squared, and we come out with 1.05 times 10 to the 16th. 10 to the negative 31st divided into 10 to the negative 15th gives us 10 to the 31st times 10 to the negative 15th, which is 10 to the 16th. And 9.6 divided by 9.1 is pretty close to 1.05. Now we consider the problem of an electron moving in any arbitrary direction in the xy plane. We indicate by these little x's here a magnetic field coming out of the blackboard, magnetic field in the z direction. And we just pick an arbitrary direction for the velocity. So let's say the velocity is in this direction. Okay? If so, well then QV is in this direction. So that QV cross B is in the direction of QV cross B, which is this direction, perpendicular to the velocity and also perpendicular to B. Being perpendicular to the magnetic field, it's in the xy plane. So here's the direction of the force. Okay, so another thing then that we can say is, well, we ask what's the path of the particle. First place, force is perpendicular to the velocity, and that's for any velocity in the xy plane. Of course, it's going to be true for any velocity in any direction. The force is perpendicular to V and to the magnetic field vector. Well, in this case, then magnitude of QV cross B is constant, provided V is constant. Okay, now why should V be constant? Well, if this is the net force is in the direction perpendicular to the velocity, which means that the component of the force parallel to the velocity in the direction of the velocity is 0. So force perpendicular to the velocity implies parallel force is 0, means that no work is done by the magnetic field. Now, under the implicit assumption that the magnetic field is the only force is that due to the magnetic field, or the only significant force is that due to the magnetic field, we conclude that no work being done gives us a constant kinetic energy, so that the velocity is constant. And here the statement is no work is done on or by the electron in this case. So it has constant velocity. Now, what do we know about constant velocity with a force perpendicular to motion? A constant force perpendicular to motion. And I guess I should write down that the force is constant, V is constant, and the mass is constant. That implies that the path is circular, and that now you have your acceleration is perpendicular to the velocity vector, and in the same plane. So the centripetal, so you have, well, the acceleration is now centripetal acceleration, 1.05 times 10 to the 16th meters per second. We ask what's the, well, we ask for a description of the path. The description of the path is now it's going to be circular. You have the centripetal acceleration, and you know that centripetal acceleration is mv squared over r. We know the velocity, we know the mass. We can solve for the radius of the circle. Okay, and we get the radius of the circle is mv squared over centripetal acceleration, and that comes out pretty close to 10 to the negative third meters. And in fact, it's going to be about 95% of that, just a little less than a millimeter. Okay. Now, I also mentioned in class, and I'm going to write it down here so we can take a look at it, what happens if the particle is more massive. If the particle is, let's say, a proton with ballpark 1800, well, just ballpark that out to 2,000 times the mass of an electron, what's that going to do to this radius? Well, the mass is going to be a lot greater, 2,000 times is great, meaning the radius of the proton, the radius of the circle that would be the path of a proton having this same velocity in this field would be 2,000 times this. 2,000 millimeters is about 2 meters, so you have a somewhat bigger path, quite a bit bigger. And that kind of gives you a little feeling about the difference in mass between a proton and an electron, or the ratio of proton mass to electron mass. You can kind of visualize that as 2,000 meters versus 1 millimeter. So I've simply written down that statement. Proton mass is about 2,000 times the electron mass, closer to 1,800, actually 1,700 and something, and you can look that up anytime you want to. And that implies that the radius for a proton moving at the same velocity is approximately 2 meters, approximately 2,000 times, since, again, the radius depends on the mass if the velocity is the same. And if the force is the same, which it would be in a proton, because the proton has equal and opposite charge to that of the electron, which I assume is common knowledge.